Hello, I welcome you all to today's lesson. We've already had our first lesson, which is on circle theory. This evening, we'll continue from where we ended. Please get your notebooks, your pens, and other items ready, and make sure you follow me step by step as I try to take you through the rest of the lessons. Now, during our last meeting, we did look at the definition for a circle, and we also looked at the parts of a circle. So I'm going to continue from that point. We'll look at the theorems and look at how to solve questions related to the theorems. But before I take you through today's lesson, let me give you a quick recap of what we did the last time. The last time during our meeting, we gave the definition for a circle, and we said a circle is a locus which is equidistant from a fixed point called the center of the circle. So you realize that from the definition we had technical terms in there which I explained, the term locus and the term equidistance. So I explained that when we say something is a locus is a set of all points or lines which satisfy specific conditions. A set of all points or lines which satisfy specific conditions. So what this definition is implying is that the specific condition that defines a circle or that determines a circle, one is an equidistance or equal distance. So one, equal distance, and two, a fixed point. So you realize I explained in the previous class that what defines a circle, one, is its center or the fixed point, and two, the equidistance or the equal distance, which in this case we term as the radius. So to draw any circle, you need a fixed point, and two, you need a radius. And after drawing the circle, I also explained to you that the perimeter of this circle, and I explained that perimeter is the distance all the way around a given shape. So either I move in a clockwise or anti-clockwise direction. So if I move in a clockwise way till I get to my starting position, this thick black edge that you are seeing, the boundaries of this circle, that is what we term as the circumference of a circle. So this is the circumference. The circumference of the circle. And I went ahead to explain what a chord is to you. I said a chord is a straight line which joins 2 points on a circle. A straight line which joins 2 points on a circle. So if you have any 2 points, I have a point here X and a point here Y. The straight line which joins these 2 points is called a chord. So the line joining this is what we term as a chord. I explained further that the chord divides the circle into segments. So anytime you bring a chord into a circle, it breaks the circle into two so that you have segments. Now the bigger portion is called the major segment, and the smaller portion is called the minor segment. So from this diagram, the circle has been divided into two portions. We have this portion and this, but this side is bigger than this side. So we call this major segment. And the smaller side is called a minor segment. I further went on to explain that this chord will also break the circumference also into two. This side, it will break the circumference into two. So I realized that from this chord, we have this section of the circumference, and then this part also of the circumference. And I said, anytime you cut a portion of this circumference off, you obtain what we call arc, or you get an arc. So with the insertion of this chord, you realize that we have this portion of the graph, of the circle, and then this portion as well. So this is an arc, and then this one is also an arc. But because this one here is smaller, we say this is minor arc. And this is the major arc. So if we are considering everything, everything, that is circumference. If you are considering everything, that is the circumference. Now when you introduce a chord, the chord breaks the circumference into two. And the portions are called arcs. The smaller side, minor arc. The bigger side, major arc. Then we also went ahead to look at what we call the radius of a circle. And we said the radius is the common distance from the center to any point on the circumference of the circle. The common difference from the center to any point. So if I draw a straight line from the center here to this point, then this line here from the center to the circumference is what we term as radius. Assuming the center is O, and then this side is maybe A, then OA is the radius. So radius is always the common distance from the center to the circumference. And I also explained that the radius is half of the diameter. So we have to determine what a diameter is. So I explained that the diameter is a type of chord. So the diameter is also a chord. The diameter is a type of chord which passes through the center of a circle. A type of chord which passes through the center of the circle. So if I'm using the same diagram, okay. Now we said this was point B and this was point A. This straight line here is joining point B to point A. And we said any straight line which joins 2 points on a circle is called a chord. So AB is supposed to be called a chord, but because it is passing through the center of the circle, we say it is called a diameter. So that's why the definition says that the diameter itself is a type of chord. So the diameter comes under chords, just that it passes through the center of the circle. So we don't use chord, but we rather call it diameter. So a straight line which joins 2 points on the circle and passing through the center is called a diameter. Now, you will realize that from our definition, I said the radius is half of the diameter. So I went further to tell you that if you are looking at this diameter, AB, if you are looking at OA, we say OA is the radius. So this OA here is half of the full length AB. If you look at the line AB, OA here is half of the total line. So that's why we say the radius is half of the diameter. Or we can also say the diameter is twice the radius. The diameter is 2 times the radius. That means when you add 2 radii, you get a diameter. When you add 2 radii. So if you look at this, we have OB. We say OB is a radius. Why is it a radius? Because it is a straight line from the center to a point on the circumference. That's the definition for radius. We said a radius is a straight line from the center to any point on the circumference. So O to B radius, O to A is another radius. So if we combine these 2 lines, then we have the diameter AB. So BO or OB plus OA or AO, when you add these 2 lines, that is BO plus OA, it will give you the full length AB, which is the diameter. So the diameter is 2 times the radius. When you add 2 radii, you obtain the diameter. Or when you multiply a radius by 2, you get the diameter. Now, I also explained what a tangent is to you. A tangent is a straight line which touches the circumference of a circle. And I explained that it shouldn't cut through the circle, but it should just touch the circumference. So if you see a line like this, this line JL, then the name for the line JL here is tangent. JL is a tangent. It is a tangent because it is touching the circumference of the circle. I told you when it cuts through, it is not a tangent. As in, if you have this line, assuming this is ST, line ST is not a tangent. It is not a tangent because it cuts through the circle. For it to be a tangent, it must touch the circumference of the circle. And that was the last definition we looked at during our last meeting. So I'm going to continue from that point. If you want any further explanation, you can look at our previous videos and make some notes down for yourself. If you have any question also, you can post it on the school page. Most of the teachers are on the page. So when you post your questions there, we are going to address them for you. So if you have any question you want to ask me, you can post it on the school page, or you can make reference to the videos that was sent on the school platform. Don't forget, it is Sethoo Aller-Aller Edu TV. So you submit them, and I'm going to go through them and give you the solutions that you require. All right, so on that note, let's move on quickly to what we want to do today. This evening, I'm going to explain some terms that are associated with circle theory. Then, I will now go further to look at the theorems with you one after the other. We'll also look at how to solve questions under the various theorems. I'm going to give you 9 theorems, and under each theorem, I'm going to give you questions under them. When you understand them theorem by theorem, I will now combine about 4 or 5 theorems in a question. Then we'll look at how to get them. So today what we are doing is to explain some terms that are associated with circle theory. Then from there, I'll look at the theorems with you. And then we'll look at questions under them one after the other. Theorem 1, Theorem 2, Theorem 3, in that order. Now, One term I'll be using more in this class, which you need to understand, is the word subtend. Subtend. I'll be using this word frequently. So you need to understand it very well before we move on with the class. Now, the meaning of the word subtend means that it is holding. Holding. Subtend means to hold. So it is holding. Now, under circle theorem, we use only two things to subtend an angle. The various parts of the circle that I gave to you, we use only two of them. One, we use chords to subtend angles. And then two, we use arcs. So anytime you are being told, or a question tells you that a given line subtends an angle, then you should know that that line is a chord. Or if they tell you an angle is being subtended, then you should know that it is either the chord that will subtend the angle or an arc that will subtend the angle. So it is only these two things that we use to subtend an angle, either a chord or an arc. Now, for your understanding, I'm going to restrict myself to the use of only the chords. So I'll be using the chords to subtend the angle throughout my teaching. However, we can also use arcs to subtend angles. The chord and the arc will all give you the same results by the end of the day. So it is better I restrict myself to the use of one of them. So I'll be using the chord to subtend angles throughout these lessons. However, always note that we can also use arcs to subtend angles. Now, I have mentioned that to subtend means to hold. So let me draw a diagram on the board, a circle. And I'm going to use that to explain the meaning of subtend. In any given circle, for all circles, angles are subtended at two places. For any given circle, angles are subtended at two places. One, at the center, two, at the circumference. Because I want you to get what we are doing, I'm going over the whole thing again. I said the word subtend means to hold. To hold. Two, I said we use only chords and arcs to subtend angles. Either a chord or an arc, is what we use to subtend an angle. However, I will use only the chords to subtend angles. Two, I'm also explaining that angles can be subtended at two places. Angles can be subtended at two places in a circle. One, you can subtend the angle at the center, and two, you can subtend the angle at the circumference. Okay, so I'm going to use a chord to subtend an angle, so I need a chord in this diagram. Remember, we say chord should join 2 points on a circle. So let me join by using a line. Now let me call this line A, B. Line AB is a chord. And it is a chord because it is joining the point A to the point B. So AB is a chord. Good. Now let's look at something. Now let me call this center O. From our plane geometry class, we learned that an angle is formed when two straight lines meet. An angle is formed when two straight lines meet. So let's look at the angle O here. You realize that angle O is created by the line, this line OA, and then the line OB. So if you join the line AO and the line BO, these two lines, when you join them together, you have this angle. Let me call this angle theta. So it means that angle theta here is created by this line OA and this line OB. Where they meet, they form this angle. Okay. So I said subtend means it is holding. Now you realize that the angle AB is holding or subtending the angle theta at the center. How do I know that? Now look at this. For a given chord, for any given chord to subtend an angle, the legs or the lines which creates the angle must have a connection with the line. In other words, it must stand on the line. So look at angle O, this angle here. Look at the two lines which create the angle. So you realize this line here is standing at the point A. Now, if I look at the second line for angle O, this leg is standing at the point B. So look at the chord AB. Let's follow the two lines. So you realize that angle O is standing on the line AB. How do you know that? Because you realize the legs of the angle O is standing on the line AB. And to know that, you just trace the legs of the angle. This is point A, this is point B. So the line AB here is the chord. Now trace which angle AB is subtending. The legs of the angle should stand on it.